Today we are proceed for the engineering mechanics unit number 2, equilibrium. Now what is meant by equilibrium? If the resultant of a number of forces acting on a particle is zero, the particle will be in equilibrium. As we know that the resultant is the single force which will be producing the same effect as that of produced by the number of forces. If that resultant force is zero, in that condition, the particle will be in equilibrium. Such a set of force whose resultant is zero is called equilibrium force. The force which brings the set of force in equilibrium is called equilibrant. The force which is acting on a body which brings the set of force in equilibrium is called as an equilibrant. As a matter of fact, the equilibrant is equal to the resultant force in magnitude but opposite in direction. As a matter of fact, what? The equilibrant is equal to what? The resultant force. The magnitude same in magnitude but opposite in direction. Now if you are considering, now let us consider these are the number of forces which is acting over the body. Okay, and the resultant of these three forces, let us consider the R, which is having some magnitude. Let us say R is equal to 10. Okay, and what is the equilibrant then? Equilibrant is an force having the magnitude same. Equilibrant is having the magnitude same but opposite in direction. Magnitude will be same, but the direction is opposite. As if you are seeing over here, the magnitude is same but opposite in direction. That is nothing but what? Your equilibrant. The resultant of these three forces R, and this R is having a magnitude of 10, and equilibrant is what? It is having the same magnitude but opposite in direction. That force is called as an equilibrant. And due to this equilibrant, if these two forces are equal in magnitude and opposite in direction, what will happen? The resultant of these two forces will be zero. That means your resultant will be zero over here. That means the resultant will be zero in that particular condition. Now, static equilibrium. What is meant by static equilibrium? The body is said to be in a equilibrium when it is at a rest or has a uniform motion. The body is said to be equilibrium when it is at rest, or in the uniform motion. According to Newton's law of motion, it means that the resultant of all the forces acting on a body in an equilibrium is zero. It means that the resultant of coplanar forces acting on a body is zero. That is summation fx, summation fy, and sum of all moment are zero. The condition of equilibrium for the coplanar concurrent force system. There are the two conditions of equilibrium. That is summation fx is equal to 0 and summation fy is equal to 0. As we know that if the summation fx is 0, summation fy is 0, the resultant will be 0. That is the condition of coplanar concurrent force system. Second is coplanar non-concurrent force system. Okay, for that condition, there are the three conditions are there. That is summation fx is equal to 0, summation fy is equal to 0, and sum of all moments are also equal to 0. This is condition for non-concurrent force system. And graphical condition of equilibrium. Now, what is the graphical condition of equilibrium? If the system of force acting on a body in equilibrium, then there is a resultant force is 0. Therefore, the polygon of force or a vector diagram must be closed figure. This is no joining of the beginning of the first force to the end of the last force, but they coincide at the point in case of coplanar concurrent force system. What it indicates that? Now let us consider there are the number of forces which is acting over the body. Okay, these are the number of forces which is acting over the body. And if we are considering this force as a side of your polygon, now let us consider this one F1, F2, F3. These are the number of forces which is acting over the body. And these forces, if you are considering as a sides of an polygon, According to the parallelogram polygon law of force, this force is considered as a one of the side of an polygon. Once this force is finished, next force will be start from the next point. Now let us consider this one is the F2 force. One after another we are taking these forces. Then the third force is considered over here, F3. And now if we are closing this fourth one, F4, what will happen? Where we have started this F1 force, F1, F2, F3, these are the sides of your polygon. One after another we are taking along with the magnitude and directions. In direction, if you see here, this incline, it is also making the same inclination. This inclination makes same inclination. F3 having the horizontal, it is having the same inclination. F4 having vertical, that is the same inclination over here, along with the magnitudes. Now let us consider this one is 10, 20, 30, 40. The same magnitude we have to consider over here. It has observed that when the resultant is 0, it means that where this force is started, polygon is started, at the same point, the last force will be coincide. It is started from this to this, this to this, this to this, and again it is closed at the same point where it is started. It means that the figure will be closed figure. That's why the resultant will be 0 over here, according to this graphical condition. In short, vector diagram or the force diagram must be closed figure. The diagram must be closed figure. It is the graphical condition of your equilibrium. If the system of force acting on a body in equilibrium, then the funicular polygon or the link polygon must be closed figure in case of an coplanar non-concurrent force system. This is the second condition of your equilibrium. For the non-concurrent force system also, it must be a closed polygon. Now let us see the next theorem is the Lamys theorem. What is meant by the Lamys theorem, that we have to see over here, and what the statement has been done by this Lamys theorem and how to apply this Lamys theorem to solve the simple problems. Now if you see here the statement, if three coplanar forces acting at a point B in equilibrium, then such force is proportional to the sine of angle between the other two forces. Mathematically, now if you see here, these are the coplanar forces, coplanar concurrent forces, which is the forces which are passing from the same point and lie on the same plane. Now let us consider this one P1 or the force P, Q and R, which makes an angle over here alpha, beta and gamma. That is, alpha is the angle between R and Q, beta is the angle between P and R, and gamma is the angle between P and Q. And according to this Lamys theorem, what it says that your P force is proportional to, now if you see here P force, it is proportional to what? The sine of angle. P force is proportional to the sine of angle between other two forces. Other two forces are Q and R, and angle between them is alpha and sine of alpha. It means that P is proportional to sine of alpha. Now similarly for the Q force is proportional to the sine of angle between other two forces, that is beta. Other two forces are P and R, and angle between them is beta. That's why sine beta, it is proportional to the sine beta. Now similarly for the force R is proportional to the sine of angle between other two forces, that is between the P and Q, is gamma. That's why R is proportional to sine gamma over here. This is nothing but what your Lamys theorem. But it says that if the force system is having, it must be contains three forces only. If there are the two forces, it is not be applicable. If there are the four forces, it is not be applicable. There must be only three forces, and forces must be coplanar and concurrent. Concurrent means what? Passing from the same point. Passing from the same point. Then we are said this is coplanar concurrent force system, and the forces must be 3. And what the statement is made, if these 3 forces are acting on a point, such forces is proportional to the sine of angle between the other 2 forces. Okay, according to this figure, if you are see here in this figure, P force is proportional to sine of angle alpha, Q force is proportional to sine of angle beta, and R force is proportional to sine of angle gamma, where P, Q, R are the 3 forces and alpha, beta, gamma are the angle between the figures. Okay, this is nothing but what your Lamys theorem, and this theorem we may prove by mathematically and simplifying the terms. Now let us see proof of this theorem, Lamys theorem proof. Now if you are considering this figure, now let us consider F1, F2, F3, these are the 3 forces, and angle made by these forces are alpha, beta and gamma over here. Now here, draw the 3 forces F1, F2, F3, one after another, and the direction and magnitude starting from the point A. Now if you see here, the another force, that is, we called it as a vector diagram. Now here, from point A, if we are starting this F1 force, which is having an angle beta over here and having the same magnitude and direction, if we are draw this F1 up to point B, since the body is in equilibrium, the resultant is 0. Resultant must be 0. The last point must be coincide with the point with A. It means that if you are drawn this F1 over here, for the force F2, this line is drawn over here for B to C, and for the F3 force, if you are drawn this vertical line over here, and it is observed that from the starting point, if you are drawn this polygon, it will be close on the same point. It means that your resultant is 0 here. The external angle ABC is equal to alpha, beta and gamma over here. If you see here in this figure, this is nothing but what your external angle, alpha, beta and gamma. Now since here AB side, if you see here A to B side is nothing but what, it is parallel to F1. B to C side, it is nothing but what, F2, and C to A side, CA side is nothing but what, your force F3. Means in this triangle, AB side is nothing but what, F2, BC side is nothing but what, your F2, sorry, AB side is your force F1, BC is having the side of F2, and CA is nothing but what, your F3. Now, as we know that this is nothing but what, your triangle and side of force, side is AB, force is F1, side BC, force F2, side CA, force F3. Now apply the sine rule of the triangle ABC. For the triangle ABC, this is the external angle, and according to the sine rule, side AB is proportional to, now here if you are drawn this, extending this line, this angle is nothing but what, 180 minus alpha, 180 minus alpha. This side is proportional to the sine of 180 alpha. Similarly for the BC side, here if you are extending this angle is nothing but what, your 180 sine beta. Now similarly for the third side F3, if you are extending this side, this angle is nothing but what, your 180 sine 180 minus gamma. Okay, it means that according to this sine rule of an triangle, side AB is proportional to sine of 180 minus alpha, side BC is proportional to sine of 180 minus beta, side CA is proportional to sine of 180 minus gamma. And as we have seen over here, side AB, BC and CA is nothing but what, force F1, F2 and F3 respectively. And as we know that according to the mathematical term, sine 180 minus alpha is nothing but what? Sine alpha. Sine 180 minus beta is nothing but what? Sine beta. And sine 180 minus gamma is nothing but what? Sine gamma. And according to this calculation, we may say that f1 is proportional to sine of alpha, f2 is proportional to sine of beta, and f3 is proportional to sine of gamma. It means that this, according to this Lamys theorem, one of the force is proportional to the sine of angle between the other two forces. The one of the force is proportional to sine of angle between other two forces. One of the force is proportional to sine of between the other two forces. This one is proved over here by the mathematical terms and triangle rule. And this is nothing but what? Your Lamys theorem. And how to use this Lamys theorem? Now let us see by solving some simple problems. Now let us see this one of the first problem. A sphere of weight 100 Newton is tied to the smooth wall by a string as shown in the figure. Find the tension T in the string and the reaction R of the wall. If you see here, this is one of the sphere having the weight of 100 Newton, and it is tied by a string, and it makes an angle over here, 15 degree angle with the vertical wall. And what we have to find out the tension in this string, as well as this sphere is connected with the wall also. That's why what will happen here, there will be one reaction which is developing R, as well as the tension which is developing inside this string. The tension which is developing inside the string, that we have to find out over here. How to find out this one? We have to first of all draw the free body diagram of that sphere. Free body diagram of the sphere as shown in the figure, and the figure shows all the forces moving away from the center of the ball. If you see here, this is nothing but what? A free body diagram of your sphere. Free body diagram is showing what? The self weight. This is nothing but what? 100 Newton is the self weight, which is always passing from the CG of the body. Then this reaction R, which is located over here due to connecting with the wall, and the tension which is developing inside the string, that is T over here and R over here, that is shown over here. And with the vertical axis, it makes an angle. This angle and this angle will be same because of it is 150, 15 degree angle over here. Now here, as per law of transmissibility of force, this reaction we may replace anywhere over the same line of action. We may put this R over here, we may put this R over here, we may put R over here, anywhere on the same line of action according to the law of transmissibility of force. Therefore, this resultant R we are showing over here like this one, and the effect will be same according to law of transmissibility. The force we may replace anywhere over the same line of action with the same magnitude and same direction. Okay, that's why we are representing this figure like this one. This R is replaced over this location according to law of transmissibility. Now let us apply the Lamys theorem. If you see here, the Lamys theorem, according to Lamys theorem, what we say that this T force, now if you see here T force, it is proportional to sine of angle between the other two forces. From the geometry, it is seen that it makes an angle of 90 degree. That's why T upon sine 90. Now here, R is proportional to the angle between these two forces. This angle. Now here, how to find out this angle? As we know that this one is vertical line and this angle will be 180. It means that 180 minus this 15 will be getting the sine of this angle. Now similarly for the 100 degree force, 100 Newton force, the angle between these two forces is how much? This is 90 degree plus this 15 degree. It means that 90 plus 15. Okay, and this is nothing but what? Your Lamys theorem we are applied over here. Force, and the force is proportional to the sine of between the other two forces, and angle what we have made over here, this one is 90, this is 180 minus 15, and this is nothing but what? 15 plus 90. Okay, these are the angle between the other two forces. Now how to find out this? Very simple term is there. Here unknown are, there are the two unknowns T and R, and this value is known to us. It means that if we are taking this sine 90 to this side, it will be multiplied to this term sine 90 over here. It means that your term will be equal to T. Okay, now here T is remain as it is. This sine 90 is we are taking to this side, it becomes some multiply over here to this whole term. It is multiplying with this whole term. Now let us calculate these terms. What we have to make the calculation? 100 into sine 90 divided by again sine. Now here we make the addition of these two terms. 90 plus 150, 90 plus 15, it becomes a 105 is equal to how much? This value will be 103.52, that is T. That is nothing but what? Here T, 103.53 Newton. By using this Lamys theorem, what we have found out? The tension in this string. Now similarly, what we have to find out? The resultant or reaction R. To find out this reaction R, again simplify this term. Now here, if we are taking this term to this side, it is again multiplying with sine this 180 minus 15. Okay, again simplify the terms and calculate the values. Now if you see here, first of all, what we have to make the calculation? 180 minus 15, 165, sine 165. Okay, 100 into sine 165 divided by again sine. Now here 90 plus again this 15, it becomes a 105 degree angle. Now simplify the term, you'll be getting 26.79 Newton. This is nothing but what? Your reaction developed at support or at wall, 26.79. And this reaction as well as this tension in the string, we have found it out by using the Lamys theorem. It is very simple terms and very simple calculation we are need to be done. This term or this tension and reaction we may calculate by using the our equilibrium conditions also. As we know that our equilibrium conditions, above problem may be solved by equation of equilibrium, that is horizontal direction, that is the force in horizontal direction, and vertical direction, that is summation Fy is equal to 0 and summation Fx is equal to 0. Now if you see here, if you are resolving this force, what will happen? This force, T force, is resolved into two components, vertical component and horizontal component. Vertical component is what? Here it makes an angle of 15 with the vertical, that's why T cos 15 over here, and the horizontal component will be, that's why T sin 15. And according to this equilibrium condition, summation of all vertical forces is equal to 0. Now here this T cos 15 is going vertically upward, that's why positive. This 100 Newton force is going vertically downward, that's why negative. If you solve this, T sin 15 minus 100 because 100 is going vertically downward. Now if you solve this one, what will happen? This 100 going to this side, it becomes a plus 100. 100 divided by cos 15. It becomes a 103.53. Again, the same value what we will be getting by using this equilibrium equations also. And next term is summation fx is equal to 0. Again, this R force is going in the right side direction, and this resolve force T sine 15 is going in the left side direction. That's why it is taken as minus. That's why R minus T sine 15 is equal to 0. This is nothing but what? Summation fx is equal to 0. Now again here, as what we have here, T value is find it out 103.53. Put this value over here, and this minus term, if you are taking to this side, it becomes a plus value. If you are taking this T term to this side, it becomes a plus value over here. That's why again 103.53 sine 15. If you solve this, again 26.79 Newton. The same value will be getting by using this condition also. By resolving the forces also, we are finding the same values, and by using the Lamys theorem also, you'll be getting the same value. It means that the Lamys theorem is useful to find out such a kind of an unknown values. Now let us see another problem. Determine the horizontal force P to be applied to an block of weight 1500 Newton to hold it in position on a smooth inclined plane AB, which makes an angle of 30 degrees with the horizontal. If you see here, the block and the weight of 1500 Newton, how much this P required, that we have to find out to keep this in same position. If it is placed over this inclined plane AB, making an angle of 30 degrees with the horizontal. Now, since the body is in equilibrium under the action of all these forces, we have to apply the Lamys theorem. Now we have to first of all draw the free body diagram of this block. The block will be like this one. The self weight is passing from the CG, that is 1500 from the CG over here. Now here, what will happen? There will be reaction R, which is developing at support, and this is nothing but what? Your self weight, that is 1500. That is shown over here in this diagram or this figure. The self weight is of 1500 Newton, which is going vertical downward. The P force, which is horizontal, and here this reaction, which makes an angle 30 with the vertical. Now here what we have to make the, if there are the three concurrent coplanar force system is there, we may apply the Lamys theorem. And according to the Lamys theorem, what we may say that this force is proportional to the sine of angle between the other two forces. This force is proportional to what? The sine of between other two forces, and this force is proportional to what? The sine of angle between the other two forces. Now let us start with the first reaction R. R is proportional to what? This angle between the other two forces are 90. That's why sine 90 over here. Next force, let us consider this P. The sine of angle between the other two forces here. This is 180 minus this 30. 180 minus this 30. And third force 1500, and the sine of angle between other two forces here, it makes an angle 90 plus this 30. 90 plus this 30. And what we have to find out? We have to find out R and P. Now let us, as we know that there are the two unknowns R and P over here, and this value is known to us. To find out the reaction R, let us take this term to this side. It means that it is multiplied with the sine 90 over here. Multiply with the sine 90, then we will be getting what? Resultant R. Resultant R. Now here, now if you solve this one, how to solve? Now let us make the calculation. 1500 into sine 90 divided by, here sine 90 plus this 30, it becomes how much? Sine 120 is equal to, how much this value is? 1732 Newton. Okay, this value will be getting what? Resultant R. Now similarly, to find out P, this term that we have to take to this side, it means that it will be multiplying with sine. Now here 180 minus 30, it becomes a sine 115. Sine 150. Okay, now put the values and solve the terms. 1500 into sine 150 divided by, again, sine 120 bracket complete is equal to 866.03. Okay, by using this Lamys theorem, we are easily find out the force P required as well as the reaction which is developing over the support by using the Lamys theorem. This is very important theorem and very applicable for your simplification of our problems and solution of your problems. Okay.